In the official victory dispatches of the time, thousands of these steel behemoths were reported destroyed, yet in reality, only 90 units ever existed. How could a machine that ignited itself more frequently than it was ever struck by the enemy become the ultimate nightmare of the Eastern Front? This is a chronicle of industrial megalomania, where the celebrated father of the Volkswagen Beetle arbitrarily produced a weapon that no branch of the military had actually ordered. Discover why crews, ensconced within their 700,000 Reichsmark fortresses, ended up literally walled in alive and were forced by mortal dread to fire blindly through their own gun barrels. It is the story of a 70-ton failure that was not vanquished by enemy tanks, but by a single, almost farcical design flaw. Why did the entire world hunt a ghost that was in truth hopelessly drowning in the mire? The truth is far more absurd than any myth. The Ferdinand heavy assault gun remains, without a shadow of a doubt, the most striking and paradoxical representative of Second World War armoured fighting vehicles, possessing a reputation that bears no rational correlation to its actual distribution on the battlefield. When analysing enemy combat reports, one stumbles upon a glaring statistical impossibility. War diaries claimed thousands of these steel colossi neutralised, despite the fact that the German industry produced only 90 units of this type, complemented by a mere 4 recovery vehicles. This immense discrepancy is explained by the machine's disproportionate psychological impact. Every German self-propelled gun featuring a muzzle brake and a boxy, angular silhouette was reflexively identified as a Ferdinand, just as every large-caliber Soviet artillery piece was broadly labelled a beast killer. Yet, behind this myth lies a chronicle of technical excess and an unprecedented squandering of resources for a microseries that remained, from a strategic perspective, entirely insignificant. The genesis of this vehicle is a masterclass in failed bureaucratic planning and the unbridled hubris of a single engineer. It stands as the only mass-produced armoured vehicle designed by Professor Ferdinand Porsche, whose name is otherwise synonymous with the people's car. The project's origin lies in a fierce competitive struggle for the contract of the heavy tank No. 6, the future Tiger. Porsche pitted himself against the firm Henschel and was so intimately convinced of his own design superiority that he ordered the commencement of production at the Nibelungenwerk plant before an official decision had even been reached. When the Army Weapons Agency prioritised Henschel's more conventional design to become the Tiger No. 1, the factory suddenly found itself in possession of 90 completed, yet now useless, chassis of the experimental vehicle 4501P type. Rather than writing off this colossal industrial blunder, the political leadership ordered in September 1942 that these orphaned chassis be converted into heavy assault guns. The technical peculiarity that made this design as fascinating on paper as it was impractical for field service was its gasoline-electric transmission. In place of a conventional gearbox, 2 internal combustion engines drove generators which, in turn, powered electric motors that moved the tracks. While this configuration eliminated gear shifting and allowed for surgically fine control, it proved extremely complex, devoured massive quantities of strategic copper, and was prone to chronic overheating. No other armoured vehicle of that era was mass-produced with such a complicated propulsion system. To transform this failed tank project into a formidable tank destroyer, the firm Alket in Berlin-Spandau was called upon, as Nibelungenwerk lacked experience with fixed superstructures. The objective was to create a machine capable of annihilating any known adversary at maximum range. For this purpose, the powerful 8.8cm Pak 43/2 was selected, an artillery piece with an impressive barrel length of 71 calibers derived from anti-aircraft defence. Since the original rotating turret was discarded and the new armament, along with a massive casemate, had to be shifted toward the rear, a fatal internal structural modification resulted. The engines had to be relocated to the centre of the hull, physically isolating the driver and radio operator from the rest of the crew in the rear combat compartment. They sat literally walled in before radiating engine blocks, without any direct access to their comrades. The original air-cooled Porsche engines, which proved notoriously unreliable, were replaced by 2 proven Maybach 12-cylinder engines of 265 horsepower each, necessitating a total redesign of the cooling system and fuel tanks. The most striking feature, however, remained the armour. The frontal section was reinforced with bolted-on naval steel plates to a total thickness of 200 mm. Such a carapace rendered the vehicle immune to the fire of all existing enemy tank and anti-tank guns. The result of these transformations was a 65-ton monster whose chassis was originally dimensioned for only 55 tons. The engineers thus created a static giant that appeared invincible in theory, but whose mechanical components were condemned to failure by overload from the moment they left the factory. Despite this titanic firepower and fortress-like protection, the planners, in the haste of preparations for the summer offensive of 1943, overlooked a decisive detail that would prove tragic in close-quarters combat. The vehicle possessed no machine gun for defense against infantry. The delivery of the final units occurred literally at the 11th hour before the launch of the scheduled summer offensive, with the very last armoured behemoth rolling out of the Nibelungenwerk assembly halls as late as May 8, 1943. This left the crews with virtually no opportunity to master a technology that was as temperamental as it was complex. Organisationally, these 90 unique specimens were divided into two heavy tank destroyer battalions, numbered 653 and 654, which together formed the Heavy Tank Destroyer Regiment 656. The strategic intent of the High Command was to employ this grouping as an irresistible steel battering ram against the deeply echeloned and heavily fortified Soviet lines in the northern sector of the Kursk salient, a mission for which the vehicle, given its technical specifications as a long-range dueling gun, was fundamentally ill-suited. The suspension, another technical eccentricity of the Porsche design featuring complex external longitudinal torsion bars, groaned under the burden of nearly 70 tons of combat weight. This resulted in a phenomenal ground pressure that turned any manoeuvre on the soft Russian soil into a high-stakes gamble. As soon as these colossi strayed from firm ground, they threatened to sink up to their hulls, reducing tactical mobility to an absolute minimum and turning the recovery of damaged vehicles into a logistical impossibility. On July 5, 1943, Operation Citadel commenced, and the absurdity of the entire concept was revealed almost instantaneously on the battlefield. While standard Soviet 76mm anti-tank shells did indeed bounce off the 200mm thick frontal armour like harmless pebbles, immersing the German crews in a bubble of perceived invincibility, a far more trivial threat lurked beneath the surface. The Soviet defenders had sown the terrain with a brutal density of mines, and the very physical mass of the Ferdinands, which shielded them from horizontal fire, now worked against them by triggering with mathematical certainty any deeply buried mine. Within the first hours of the attack, what was supposed to be a technological triumph transformed into a static disaster, as numerous vehicles were left immobilized with shattered tracks or mangled road wheels without having sustained a single direct hit from an enemy tank. A Ferdinand stripped of its mobility immediately became an ideal practice target for Soviet artillery, which focused on systematically shelling vulnerable external components, such as sighting optics and gun barrels, to blind and disarm these helpless giants. In this precarious situation, the absence of an integrated close defense weapon took a brutal revenge. Isolated crews within their steel fortresses had to watch powerlessly as Soviet infantrymen approached the paralyzed giants to place explosive charges or incendiary bottles on the engine ventilation grills. The German soldiers were reduced to almost grotesque acts of desperation, firing submachine guns blindly through the long barrel of the main gun, or briefly cracking open hatches to toss hand grenades, thereby exposing themselves unprotected to the fire of enemy snipers. The psychological effect was completely inverted. The vaunted miracle weapon revealed itself to be a rigid steel trap from which there was almost no escape for the crew in the event of fire or mechanical failure. The centerpiece of this rolling fortress was its disproportionately long cannon, featuring a barrel length of 6 meters and 30 centimeters, whose ballistic capabilities far exceeded any reasonable tactical requirements of the era. The muzzle velocity of the armor-piercing shells, weighing over 10 kilograms, reached 1,000 meters per second, resulting in a trajectory so flat that precise aiming felt almost superfluous. The pure kinetic energy alone was sufficient to punch through any known enemy armor at distances exceeding 2,000 meters. However, this brutal firepower was purchased at the cost of an internal design flaw that drastically diminished the vehicle's operational value. To compensate for the titanic recoil of the weapon and the mass of the casemate located on the rear third of the hull, engineers were forced to relocate the entire power plant to the center of the chassis. This configuration led to a bizarre spatial division of the 6-man crew, where the driver and radio operator were positioned in a separate forward compartment, hermetically isolated from their comrades in the rear combat space by screaming, heat-radiating engine blocks. Direct communication was impossible, relying entirely on an internal intercom system whose reliability under the heat of battle and the constant vibrations of the non-synchronized engines often failed miserably. The logistical nightmare extended to fuel consumption, as this hybrid propulsion system devoured up to 1,200 litres of gasoline per 100 kilometres in off-road conditions. Given a fuel tank capacity of only 540 litres, this limited the operational radius to laughably short distances. Supplying these gasoline-soaked monsters posed insoluble problems for the logistical units, as the vehicle had to be refueled practically every few hours just to maintain any degree of mobility. Added to this was an extreme thermal load. The air intake ducts for the engines and generators squeezed into the centre of the hull were hopelessly undersized. This caused the components to overheat and catch fire en masse during simple marches, even without enemy contact. Even the optics were a compromise. The gunner had to settle for a telescopic sight offering only 5 times magnification, a glaring disproportion to the phenomenal range of the main armament, which in practice often rendered the cannon's theoretical potential unusable on the battlefield. The operational deployment of July 1943 in the Ponnuri sector and near the Maloarkhangelsk railway station drastically demonstrated how profoundly the theoretical calculations of the engineers diverged from tactical reality. The 654th Heavy Tank Destroyer Battalion deployed its machines in an unprecedented wedge formation, with the Ferdinands acting as steel battering rams at the tip of the assault, intended to breach Soviet defensive lines through the sheer force of their mass and firepower. Initially, the concept of invulnerability seemed to hold true, as the frontal armour resisted even concentrated fire from 76mm anti-tank guns, and the main armaments of T-34 tanks, shells shattered harmlessly against the hardened surface, leaving only insignificant scratches on the 200mm thick steel plates. However, the physical law of enormous ground pressure became a fatality the moment the assault spearheads became entangled in deeply echeloned minefields, the density of which had been massively underestimated by German reconnaissance. While the detonations of heavy anti-tank mines rarely ruptured the hull itself, the sheer shockwave annihilated the delicate running gear and the sensitive electric traction motors within, instantaneously transforming these 65-ton colossi into immobile bunkers. Recovery under enemy fire proved to be a logistical impossibility, as no existing recovery vehicle in the Wehrmacht was capable of moving such a mass individually in muddy terrain. The necessary coupling of up to 5 18-ton tractors in a series created a static target that was far too easy for the opposing artillery to strike. In this moment of forced immobility, the most serious design flaw, ignored by planners obsessed with long-range combat, was brutally exposed: the total absence of secondary armament for close-range defense against infantry. Soviet soldiers were able to approach the gigantic silhouettes in their blind spots, as the crew had no way to effectively defend themselves against attackers in the immediate vicinity without leaving the protection of the armour. In their desperation, the gunners were reduced to opening the breech of the main gun to fire a submachine gun blindly through the barrel, which was over 6 metres long. This grotesque improvisation symbolised the failure of the entire high-technology concept. Thus, a weapon system whose development had swallowed millions of Reichsmarks was neutralised not by equivalent armoured technology, but by simple magnetic charges and incendiary bottles, while the isolated crew remained entombed within. After the immediate fighting subsided, a statistical analysis of the events in the Kursk salient began, revealing a profound chasm between propagandistic victory reports and the physical reality on the ground. The Heavy Tank Destroyer Regiment reported the destruction of over 500 enemy armoured vehicles, a figure which, after a rigorous technical analysis of ballistic conditions, the extreme narrowness of the engagement front of only a few kilometres, and actual Soviet inventory lists, must be classified as statistically highly improbable and vastly exaggerated. While German crews credited every smoking T-34 to their own tally, they ignored the fact that a large portion of enemy losses was caused by mines, artillery or other tank units, placing the Ferdinand's true effectiveness in a far less glorious light. Parallel to this statistical distortion, a technical antagonist appeared on the Soviet side, shattering the concept of impenetrable armour through sheer physical brute force. The Su-152 self-propelled gun, significantly nicknamed the Beast Killer. Instead of attempting to pierce the 200mm frontal plate with high muzzle velocity, these machines fired high explosive shells weighing nearly 50 kilograms from their 152mm howitzers. The kinetic energy of such an impact was so phenomenal that it did not necessarily need to penetrate the armour. The shock alone was often sufficient to burst weld seams, pulverize internal optics, or shift the multi-ton casemate on its chassis, leading to the immediate failure of the entire electrical system. A detailed examination of the 21 steel corpses abandoned on the battlefield near Ponyri Station by Soviet engineers finally confirmed the failure of the concept, as only a single vehicle showed evidence of a lateral penetration. The overwhelming majority of losses resulted not from enemy action, but from the inability of logistics to recover the 65-ton machines under combat conditions, as this would have required up to 5 synchronized 18-ton tractors, an operationally unfeasible maneuver under constant artillery shelling. Consequently, crews were forced to scuttle their own technically intact but immobile vehicles to prevent them from falling into enemy hands, destroying more Ferdinands with German explosive charges than Soviet guns ever did. A particularly bizarre example of the design's inadequacy was provided by a captured specimen which, during a towing attempt by the Red Army, sank into the sandy soil despite the combined effort of 4 heavy-tracked tractors, whereupon its gasoline-electric drive finally gave up the ghost under the weight of its own mass. The 48 surviving vehicles that technically escaped the disaster of the Eastern Front were recalled, in late 1943, to the Nibelungenwerke facilities in Austria to undergo an exhaustive general overhaul. This intervention was intended to finally address the fundamental design flaws that had been so ruthlessly exposed. In a bureaucratic turn of events with almost ironic undertones, a decree was issued to rename the vehicle the Elefant, a designation far more faithful to the technical reality of a colossus whose total mass had climbed to 70 tons, reflecting the pachyderm-like sluggishness of its new configuration. Engineers were forced to laboriously bore through the massive frontal armour of the hull to finally install a 34 Type machine gun in a ball mount. This elementary defensive measure, the initial absence of which had cost so many lives, was complemented by the addition of a modern commander's cupola equipped with periscopes, ensuring the commander would no longer have to direct the battle virtually blind. However, no sooner had this modernisation been completed than the High Command made the questionable strategic decision to transfer the 1st Company of the 653rd Heavy Tank Destroyer Battalion to Italy to counter the Allied landings at Anzio and Nettuno. These superpowered tank destroyers, designed for long-range ballistic duels in the Russian steppes, were sent into a mountainous theatre of operations where ancient bridges and winding roads had never been intended to support an axle load of 70 tons. The result was a logistical fiasco where the Elefants were neutralised less by enemy fire than by the topography itself. They collapsed along with bridges under their own weight, or became immobilised on steep inclines due to the chronic overheating of their complex electric traction motors. While the 1st Company was literally bogged down in the Italian mountains, the other 2 companies were thrown back to the Eastern Front in Galicia in the spring of 1944. There, they encountered another insurmountable physical obstacle, the mud season. The ground pressure, excessive due to tracks that were relatively narrow for such a mass, caused the vehicles to sink into the sodden earth up to their hulls, transforming the engine's power into mere geysers of sludge without generating any forward propulsion. During the retreat west of Ternopil, the cycle of self-destruction repeated once more. Faced with a lack of spare parts for their exotic hybrid motorization and the impossibility of towing such masses, the once imposing fleet was reduced within a few weeks to a mere handful of specimens still capable of movement. The final chapter of this technical tragedy unfolded in April 1945 at the gates of Berlin, where the 614th Heavy Tank Destroyer Company concentrated the last 4 remaining operational specimens. In the vicinity of Zossen and Wunsdorf, these mechanical relics were integrated into a hastily assembled combat group named Ritter. In this terminal phase of the conflict, their chronic lack of power and absent mobility mattered little, as they functioned effectively as stationary steel bunkers within the defensive line. It is a lacerating irony that this complex weapon system, originally conceived for offensive breakthroughs across the vast distances of the Russian steppe, ended its existence as an immobile roadblock in a sea of urban ruins, where its superior sighting optics and the enormous range of its cannon were rendered entirely useless by the short lines of sight between burning buildings. The final balance sheet of this engineering excess is, from a military economic perspective, absolutely devastating. The Herculean effort expended on the development, conversion, and extremely costly maintenance of the gasoline-electric drive bore no rational proportion to the minimal strategic benefit of only 90 produced units. The Elephant was a symptomatic symbol of late-war German armament philosophy, which gambled on gigantic, handcrafted miracle weapons instead of prioritizing functional and mass-producible solutions. In this manner, the vehicle tied up precious raw materials such as copper and rare alloys in a construction that statistically spent the majority of its existence in repair shops or mired deep in the mud. Yet, despite its fatal technical flaws, constant engine compartment fires, and laughably low production numbers, this steel monster achieved a paradoxical psychological victory that far outlasted its physical demise. In the collective perception of enemy forces, its massive angular silhouette was etched so deeply as the embodiment of threat that until the final day of the war and for a long time thereafter, practically every German tank with a long barrel was fearfully identified as a Ferdinand. Thus, Professor Porsche's failed experiment attained, at least as a spectre, an omnipresence on the battlefield that technical reality had never allowed it to achieve.